we need to define the mole and molar mass. This is a mole, but it's the wrong kind of mole. This is biology and we are studying physics, so we can get rid of that. A mole is a certain number of particles, and that number is 6.02 times 10 to the 23 particles. L is also known as the Avogadro's constant, and this is the number of particles that you have in a mole. For example, you could have a mole of bananas, which means you have 6 times 10 to the 23 bananas. A mole of atoms is 6 times 10 to the 23 atoms, and so on. So a mole contains 6 times 10 to the 23 particles of whatever it is. The molar mass is the mass of 1 mole of those particles. For example, what is the molar mass of nitrogen gas? Well, nitrogen has a mass, an atomic mass of 14, and you have, what is the mass, the molar mass of 6 times 10 to the 3 lots of 14? It will weigh 14 grams. However, if the molecular mass of nitrogen is 14 plus 14 is 28, the mole of nitrogen gas, the diatomic molecule, is the mass of 6 times 10 to the 23 particles, which will be 28 grams. What is the molar mass of water? Well, water is made of 2 hydrogens and an oxygen. Oxygen is 16, hydrogen is 1, so it's going to be 16 plus 2 is 18 grams is the mass of 6 times 10 to the 23 particles, in other words, 1 mole of water. A little exercise, you can find the volume of the room, and remember that at standard temperature and pressure, a mole of gas has a volume of 22 times 10 to the minus 3 meters cubed. Find out how many moles there are in the room. And once you know how many moles are in the room, bear in mind that most of it is nitrogen N2, so that has a molecular mass of 28. Try to work out how many moles there are, and then how much all that gas will weigh. So what is the mass of the gas in this room?